Hello everyone, welcome to this tutorial on PC to PC data transfer through RS232 serial port using C programming. An RS232 serial port has 9 pins like this, out of which we are going to need only 3. Pin 2 which is receive data pin, pin 3 which is transmit data pin, and pin 5 which is ground. Now this port is available as a DB9 connector. You may have noticed it on your CPU also. We will connect serial ports of 2 PCs like this. Transmit pin of one PC connected to receive pin of other, and vice versa. That is pin 2 of first PC connected to pin 3 and pin 3 of first PC connected to pin 2 of other PC, and ground connected to ground. These are the standard port addresses for most of the PCs. Ours is COM1 with address 3F8. If you don't know your port address, you can run this program in Turbo C. It will give you your port address. These are the different registers that we need to configure in order to transfer data from PC to PC. The first one is interrupt enable register. As we don't want any interrupts, we will make it 0. Now at this point we should understand the role of DLAB bit. You may have noticed in this table that interrupt enable register and divisor latch MSB has same address, and also base register and divisor latch LSB register has same address. So how they are differentiated? They are differentiated by DLAB bit. DLAB is a bit in line control register. When it is 0, we have interrupt enable register and base register. When DLAB is made 1, the same registers behave as divisor latch LSB register and divisor latch MSB register. By the way, base address is the address of my COM1, which happens to be 3F8 as shown in the last slide. So to access divisor latch LSB and MSB, we want to make DLAB equal to 1. As I told, DLAB is the 8th bit in line control register. If we make it 1, line control register becomes 80 in hexadecimal. So this is how we get 80 here. Now what is the use of divisor latch LSB and MSB register? They are used to get desired baud rate. The maximum baud rate we can have is 115200 bits per second. When we divide it by 2, we get next baud rate of 57600. When we divide it by 3, we get next baud rate of 38400, and so on. So this second column shows all the divisors in decimal. If we convert them into hexadecimal, 2 of the values at the top are going to exceed 8 bits. So we need 2 bytes, divisor latch low byte and divisor latch high byte. Our desired baud rate for our application is 38400. So lower byte becomes 03 in hexadecimal and higher byte becomes 00 in hexadecimal. So we put 03 in divisor latch LSB register, whose address is base plus 0, and 00 in divisor latch MSB register, whose address is base plus 1, when DLAB is made equal to 1. Now next we configure line control register. These last two bits are used to set word length. If we want it to be 8 bits, then we should make these two bits equal to 1 and 1. We won't change any other settings, so total value becomes 03 in hexadecimal. So line control register becomes 03. Next is FIFO control register. FIFO is basically first in first out buffer. Our buffer size is 16 bytes, so we can set the limit of 14 bytes to be safe, so make it equal to 11. Now this 64 byte FIFO is available only in very selected ICs. We have 14 byte FIFO, so make this bit equal to 0. Next is a reserved bit, so make it 0. We don't want DMA mode, so make it 0. We want to clear, transmit and receive FIFO before data transfer, so make this bit 2 and bit 1 equal to 1. To be able to transmit and receive through FIFO, we should make bit 0 equal to 1. So FIFO control register becomes 11000111, that is C7. That's why we have C7 here. Next we want to configure modem control register. Bit 6 and 7 are reserved, so make them 0. Bit 5 is for auto flow control, which is available only in 16750 UART, so make it equal to 0. We don't want to go for loop back mode, so make next bit also equal to 0. Out of auxiliary output 1 and 2, output 1 is usually disconnected and output 2 is connected to external circuit. So bit 3 becomes 1 and bit 2 becomes 0. This is 1 and this becomes 0. Bit 1 and 0 are made equal to 1 to activate request to send and data terminal ready lines. So modem control register becomes 0B in hexadecimal here. Next is line status register. If you receive some data in receiver buffer, then bit 0 becomes 1 automatically. That means data is ready to be read. Now let's try to understand our C program. In order to transmit and receive data from port, we will use two commands. One is in port B and out port B. These are the two functions in dos.h. So we include dos.h header file. Then, as I already told you, our port address is 3F8. I also told you that 0th bit in line status register tells us about incoming data. We declare a variable LSR to store contents of line status register. These two integers, data in and data out, are self-explanatory. Now referring back to our table, write 0 onto interrupt enable register, whose address is port plus 1. Write 80 to line control register whose address is port plus 3. 03 for divisor latch low byte and 00 for divisor latch high byte. 03 to line control register to set word length of 8 bits whose address is base plus 3, port plus 3. C7 to FIFO control register and 0B to modem control register whose address is port plus 4. Now to send and receive data we implement a do while loop. First we read the contents of line status register whose address is port plus 5, and then we AND it with 1 to check if its bit 0 has become 1. If it has become 1, it means some data is received and ready to be read by receiver buffer. So we read it from port using import B command, and then we print it using %C. Now if we press any key on keyboard, it is identified using KB hit function. KB hit means keyboard hit. It is a function from Conio header file. We store that character entered by user into data out variable and send it to serial port using outport B function. Lastly, if the key we have hit has ASCII code equal to 27, which happens to be escape key on our keyboard, get out of the do while loop. That's it. Here one end of RS232 cable is connected to serial port using 1-to-1 connector. Second end is now I am connecting to serial port of second PC. I am opening Turbo C now. This is the same program that I have just explained to you. And the same program on second PC also. Now I run the program on first PC by pressing Ctrl F9. Similarly, I run it on second PC. Now I am hitting keys on keyboard of second PC and you can see characters displaying on monitor of first PC. Here I hit keys on keyboard of first PC and they appear on monitor of second PC. Now I exit program on both PCs. Thanks for watching.